Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing reactions involving cleavage of carbon oxygen bond in alcohols. Under that I have discussed reaction with hydrogen halide, dehydration, and its mechanism I have discussed. Now I am going to discuss oxidation. Oxidation of alcohols involves the formation of carbon-oxygen double bond with cleavage of an OH and CH bond. Last class I have also discussed esterification. In that you have seen that OH bond was breaking. Now here in oxidation what will happen? Oxidation of alcohols involves the formation of carbon oxygen double bond with cleavage of an OH and CH bond, means breaking of OH and CH bonds. Means CHOH. Suppose it is a CH3OH, methyl alcohol. You can take example. Then here that two type of bonds are there. Here two types of bond will break. C and H bond will break. CH3OH. Then with C3 hydrogen is attached. Correct? And only from that carbon OH is attached. Then here two bond will break. First C and H bond will break. Another O and H bond will break. Then what will happen after breaking the bond? Then when hydrogen C and H bond will break, then hydrogen will go as H plus. Then carbon will have negative charge. And when OH bond will break, then what will happen? Then here oxygen will have negative charge. Then carbon and means on carbon there will be, you can say, electron. And here when OH bond will break, then here on oxygen also carbon will be there. Then now carbon and oxygen will have electron, one electron. Then they can make one bond. Then now it became double bond. C and O, single bond was there. Now it will be double bond. Okay. Such a cleavage and formation of bonds occur in oxidation reaction. These are also known as dehydrogenation, because here two hydrogen is going outside. Two hydrogens are leaving. That's why it is also called dehydrogenation reaction, as these involve loss of dihydrogen from an alcohol molecules. Depending on oxidizing agent used, a primary alcohol is oxidized to an aldehyde, which in turn is oxidized to carboxylic acid. It depends upon oxidizing agent. Primary alcohol is oxidized to an aldehyde and this aldehyde in turn is oxidized to carboxylic acid. Okay, means we will get due to oxidation, first alcohol will convert into aldehyde, means CHO, and this CHO on further oxidation it will give carboxylic acid. This is very important reaction. Then here suppose you have taken RCH2OH. RCH2OH. R is alkyl group. Then on oxidation this H2, this H2 CH2OH, then CH2, this H2, because oxidizing agent will be there. Oxidizing agent will be there, then that will supply oxygen. Then this H2 and O will form water, H2O. And because two hydrogen gone, hence here it will form double bond. With carbon and oxygen single bond was there, but from the same carbon two hydrogen gone. Then there now single bond will become double bond, because this H2 plus O it will form H2O. Correct? Or a stepwise, if you will see that first it will convert aldehyde, means CH2OH, that H2 gone, then what is remaining? CHO or COH is remaining. RCH2OH was there, 2 H2 gone, then COH remaining, COH. Then this C and O has a double bond, and H is there. H is attached with carbon. There carbon and oxygen will have double bond, and H will join with carbon, means aldehyde is formed, RCOH or CHO you can tell, RCHO. Then this H is attached to carbon. Now this aldehyde on further oxidation what will happen? Now this carbon oxygen double bond was there, that will be as it is, it will not break because it is strong. Then now what will happen, because further oxidation means carbon hydrogen bond that will break and oxygen will come there. Oxygen hydrogen bond will break, and there oxygen will join with and means new oxygen will join with carbon. Carbon has two valency, then one valence it will join with carbon and other with hydrogen. Correct? Means OH will become OH. CH bond now it will become OH bond. Correct? Then now molecule will be COH and one more oxygen, means C double bond O. Now it became carboxylic acid, C double bond O and OH, carboxylic acid. Then here important thing is that C and H bond first it will break and oxygen will join with carbon and with one valence, and with other valence hydrogen will join, because from here from CH bond when it will break, H will go as H plus, correct? And that when oxygen will join because now carbon Oxygen will join with carbon, and oxygen is electronegative element, you know. Then it requires electron. Then when hydrogen gone outside, then it went outside, leaving the electron to carbon. Correct? Carbon left the electron and then it went. That's why it went as H plus. And carbon was having negative. Negative means electron was with carbon. Now oxygen will come, which is electronegative. It will take the electron. It will take the electron and bond will form. Correct? Bond will form. And because hydrogen bond temporarily it has broken, that again will attach with oxygen, because now oxygen will supply electron to hydrogen. Correct? First it will make a double bond. Oxygen will make double bond. But quickly, because H is there, then now that double bond will become single bond. And that electron will be given to hydrogen. Electron will be given to hydrogen. Hence now RCHO means aldehyde became RC-OOH. CH now converted to OH, and already C and O double bond was there. C and O double bond was there. Hence now we will get carboxylic acid. A strong oxidizing agent. Strong oxidizing agents such as acidified potassium permanganate are used for getting carboxylic acids from alcohols. From alcohols, here you are using potassium permanganate. Potassium permanganates are used for getting carboxylic acids from alcohol directly. If you will use acidified potassium permanganate, then without converting to aldehyde, directly you will get carboxylic acid. This you remember, question is asked. This happens only in presence of strong oxidizing agents. Chromium oxide, CrO3. Chromium oxide in anhydrous medium. Anhydrous medium means without water. CrO3 in anhydrous medium is used as the oxidizing agent for the isolation of aldehyde. Now from alcohol, if you want to get only aldehyde, then chromium anhydrous chromium oxide can be used. Chromium oxide in anhydrous medium, anhydrous, no water, then you will get aldehyde only. You will get aldehyde, and this can be isolated, means you can separate it, aldehyde. Only aldehyde can be isolated. Means RCH2OH. RCH2OH means R is alkyl group. In the presence of chromium oxide, directly you will get aldehyde, only aldehyde you will get. You will not get carboxylic acid. But if you will use acidified potassium permanganate, it is a strong oxidizing agent, then you will get directly carboxylic acid, no aldehyde. Okay. A better reagent for oxidation of primary alcohols to aldehydes in good yield is a pyridinium from the pyridine. It comes out, it is made pyridinium chlorochromate, PCC. P means pyridinium chlorochromate. PCC. Okay. Then a better reagent for oxidation of primary alcohol to aldehydes in good yield. In good yield age, if you want more quantity, then PCC is used. Means 1P means pyridinium and CC means chlorochromate. PCC. A complex of chromium trioxide with pyridine and HCl. Okay, what is actually PCC? Then it is a complex. It is a complex of chromium trioxide with pyridine and HCl. When you will mix, if you will take pyridine, HCl and chromium trioxide, then you will get PCC. Means pyridinium chlorochromate. Then now by reaction you can understand. Now suppose butanol is there. Butylene alcohol means one double bond is there. Okay, one double bond, it is a butane, but a double bond is there. Second, that is a second and third carbon, second and third double bond is there. It is actually, alcohol is joined there. OH is joined there. Butylene alcohol. Then in presence of a PCC, what will happen? That this OH, this is actually primary alcohol, because OH attached to the carbon, it is attached only with one carbon. Chain is long, but it is attached with only one carbon. That's why it is a primary alcohol. And then in the presence of PCC, means pyridinium chlorochromate, this OH will convert to CHO. Hydroxyl group will convert into aldehyde group. Okay, then now we will get product CH3, CH double bond, and in the end CHO. In the end CHO. Correct? Then now here you can see in the beginning it was 4 carbon. Now again it is a 4 carbon. Only difference is that CH2 OH was there in the last carbon. CH2 OH was there. Now this H2 CH2 OH, then this H2 gone. This H2 has gone as a H2O. Then what is remaining now? COH. Then here C and O will be double bond. C and O is joined with double bond and H is joined with hydrogen, and 2 hydrogen gone as H2O, because this oxidizing agent was there, PCC. Okay. Then that's PCC supplied the oxygen and H2 converted into H2O, and it went as a water molecule. And what is the remaining? Then remaining will be now OH converted into aldehyde group, CHO group. Then butanol aldehyde you will get. Okay. Butanol, you can say butanol Al means aldehyde, or butanaldehyde. Butanaldehyde you can tell, because double bond is there between carbon number 2 and 3. Then butanol you can tell, or you can say butan 2 Al means aldehyde. Now if secondary alcohol, this is a primary I told you. Now if secondary alcohol is there, then what will happen? Secondary alcohols are oxidized to ketone by chromic anhydride, CrO3. if you will take only CrO3, then secondary alcohol will convert to ketone. And this reaction is very simple. Here you take the example, secondary alcohol means what? Now carbon to which OH is attached, that carbon is attached with two other carbon, R and R. Then it became, R means alkyl group has carbon, then it is attached with two carbon. That's why it is called secondary alcohol. Then now 2R is attached and third one is OH. One more valence is remaining, that from that H is there. H is attached. Correct? Then now it became R, carbon is attached with R, one OH and one H. Then now in the presence of chromium oxide, CrO3, what will happen? That with oxygen, in OH one H was there, and with carbon one H was attached. Correct? Then now both hydrogen, with carbon one hydrogen was there, with oxygen one hydrogen was there. Then now these two hydrogen will go as H2O in presence of oxidizing agent CrO3, chromic anhydride. CrO3 is called chromic anhydride, CrO3, because this CrO3 will supply oxygen. Then both hydrogen just will come out in the form of water, H2 plus O, H2O. And then what will happen? When hydrogen will go, when hydrogen either from carbon or oxygen it will go, and now carbon and oxygen double bond will be formed. Double bond. Now it was single bond, now it will become double bond. Because hydrogen will go as H plus, leaving its electron, and H will also go as H plus, leaving its electron. Then now these two electron, okay, they will make double bond. Electron is on oxygen also, electron is on carbon also. Okay, then easily double bond will be formed. Okay, then now on carbon only 2R is remaining and oxygen is remaining with double bond, CO, double carbon oxygen double bond. Then it is called ketone. Both R may be same or different. If one R is methyl group, other may be other, like alkyl, propyl, anything. But anyhow, we will get ketone. Then primary alcohol gives aldehyde. Secondary alcohol gives ketone. What about the tertiary alcohol? Then now just you think for the tertiary alcohol, what will happen. Then now here I am telling you, tertiary alcohol do not undergo oxidation reaction. Now think why it will not go oxidation. Tertiary alcohol do not undergo oxidation reaction. Why? Because now with carbon, tertiary alcohol means now carbon is attached with three other carbon in the form of alkyl group. Three alkyl group may be attached. Then on that carbon no hydrogen is there, only OH is there. OH is there because it is tertiary alcohol. OH attached to the carbon, that carbon is now attached with three alkyl group. Hence it is called tertiary alcohol. Because each alkyl group means what? carbon, that this carbon is attached with 3 carbon. That's what is tertiary alcohol. Then here only one H is there, OH. Then one H will not go. It will not go as H2O. It will be as OH. And this oxidation reaction will not take place. Okay. Tertiary alcohol do not go under oxidation reaction. Under a strong reaction condition, such as a strong oxidizing agent KMnO4 and at elevated temperature, means high temperature, cleavage of various carbon bonds takes place, means carbon bond will break in presence of a strong oxidizing agent like KMnO4 and elevated temperature, means at high temperature carbon bond can break. Then what will happen? Cleavage of various C and C bonds takes place and a mixture of carboxylic acids containing lesser number of carbon atoms is formed. Here you can say carbon bond breaks also, but for that a strong oxidizing agent like KMnO4 is required, and also very high temperature is required. Okay, as for example RCH2OH, in presence of as a catalyst copper and temperature is 573 Kelvin, high temperature. Then here R and CH2OH is there, then R and C bond will break. But here that bond will break, but here what will happen first, that H2 will go, H2 will go RCH2OH, then this H2 will go as water molecules H2O. Then now you will get this is actually primary alcohol, then it is giving aldehyde, and secondary alcohol, that is giving ketone. Already I told you. Tertiary alcohol in presence of copper at same temperature 523 K, all three reaction takes place, means primary alcohol, secondary alcohol, tertiary alcohol, all reactions takes place in presence of copper and same temperature 523 K. Then now tertiary alcohol in presence of copper as catalyst and high temperature 523 K. What will happen here? That now this H2 in this case what will happen? That CH3 from that any alkyl group is there, then there CH3, from that actually 2 hydrogen may go, 2 hydrogen CH bond will break, and that hydrogen can go as H2O, correct, from the alkyl group like methyl, CH3 was there, from that 2 hydrogen can go as H2O, and there you can say this when this hydrogen I was talking about, that OH was that, and actually I told you that there tertiary alcohol do not undergo oxidation reaction, but here you can see one possibility is there, that 2 hydrogen from the carbon. Methyl group is there, 3 alkyl group is there. Then with any one alkyl group, that not 2, 1 you can consider, 1 hydrogen can go, and OH will also go. OH will also go in the form of H2O. OH group was attached in tertiary alcohol, OH was there. And H it will take from the alkyl group hydrogen. In alkyl group hydrogen was there, 1 hydrogen it will take, and now OH and H will become water, and then it will go. Then when OH will break the bond, then OH will go with electron, carbon will become positive, and H will go from the alkyl group. Then when H will go as a H plus, then that carbon will become negative. Then negative and positive, that will make one bond. Now single bond will become double bond, because from the carbon OH gone, as OH minus, that carbon will have positive, and other carbon H has gone as H plus, and then carbon will have negative. Then positive and negative carbon, they will make one bond. Now it became single bond will become double bond. Okay. Then now here you can see what happened. Then in first case, in case of primary alcohol, aldehyde was formed. In secondary, ketone was formed. But in tertiary, dehydration reaction takes place. In tertiary alcohol, what will happen? That is the dehydration reaction will take place. Correct? Dehydration reaction will take place. H2O means H2O molecule will go and double bond will form. Correct? Then when the vapors of a primary or secondary alcohols are passed over heated copper at 573 Kelvin, dehydrogenation takes place, and an aldehyde or a ketone is formed, while tertiary alcohols undergo dehydration. You have to understand here that in primary alcohol and secondary alcohol, H and gone, 2H gone from there. Correct? That's why it is called dehydrogenation. Only 2H gone. But here in tertiary alcohol, it is H2O is going outside, OH and H is going outside. Correct? Then OH and H is going outside. It means it is not using oxidizing agent. Okay, that oxygen is not required. OH and H, they are forming water and going only through molecules. But in the other two cases, primary and secondary, oxygen was required because this H2 was there. Correct? H2 was present there. Then they went only H they have left. H they have left in primary and secondary alcohol. Correct? Not the oxygen. OH was there, but OH was as it is. But now in tertiary, that OH is going, OH and H both are reacting from the molecule, and then it is going as a water. But in other two, H from the molecule only hydrogen gone. Correct? But it went as H2O. That time oxygen was required from the oxidizing agent. But here, even the this situation is same. copper. All three have, in presence of copper only, reactions are taking place. Actually, copper, this vapors of primary or secondary alcohols are passed over heated copper. Correct? As a catalyst at 573. But here in tertiary, OH, in the molecules OH and H both went as H2O and double bond formed. But in other two cases, H2H gone. Dehydrogenation take place, not dehydration. Dehydration means removal of water, but dehydrogenation means removal of hydrogen. Then during removal of two hydrogen, it went as water because that oxygen came from the this oxidizing agent. Correct? Oxidizing agent. Correct? Or this things. But from the molecule, it went as a HH only. For the molecule, dehydrogenation taken place. Dehydrogenation. But in tertiary, dehydration has taken place. Then this I have discussed about the primary, secondary and this tertiary alcohol oxidation. Only in two cases oxidation takes place. Tertiary does not go under oxidation. And one important thing I want to hear, biological oxidation of methanol and ethanol in the body produces the corresponding aldehyde followed by the acid. In our body, oxidation takes place. That is called biological oxidation. Biological oxidation of methanol. In our body, alcohol also forms. You should know. In our body, methanol forms. Then what happens to that methanol? That I am telling you. Biological oxidation of methanol and ethanol in the body produces the corresponding aldehyde followed by the acid. After that, it will convert to acid. At times, the alcoholics by mistakes drink. Here you should know, at times the person, people say, that is called alcoholics person. They will drink it. People drink the alcohol, you know. Then at times the alcoholics, peoples are called alcoholics. Then at times the alcoholics by mistake drink ethanol mixed with methanol, also called denatured alcohol. When ethanol is mixed with methanol, then little quantity of methanol, if it is mixed, then that alcohol is called denatured alcohol. Okay, you know that methanol is deadly poisonous. Ethanol is non-poisonous. That's why all wines are made from ethanol. Ethanol is non-poisonous, but methanol is deadly poisonous. Then knowingly methanol is mixed with ethanol so that people should not drink. Then this alcohol is called denatured alcohol. And the purpose of mixing methanol is that people should not drink, and it is used for industrial solvent. It is used as industrial solvent. Okay, for industrial purpose, industrial use, this is done. Despite that, some people, because they might be not knowing all the things, they know only alcohol. Different type of alcohols are there. The ordinary people don't understand. They drinks, and many times many people died. Okay, this is a very, very important point here. Then this denatured alcohols, sometimes people will drink. In the body, methanol is oxidized first to methanol. In our body, methanol may be there, ethanol both may be present. Then in the body, methanol is oxidized first to methanol, means formaldehyde. Okay, this methanol only one carbon, formaldehyde, and after that, and then to methanoic acid. After that, it will convert to formic acid. Methanol, only one carbon is there, that's why it's called formaldehyde. Then formaldehyde will give to next step, it will convert to formic acid. That is called methanoic acid, which may cause blindness. This is the important things. Mechanism is this. If people will drink methanol, suppose it goes to the body, methanol if goes to the body, then this methanol will convert to methanol, methanol aldehyde, and that will convert to methanoic acid, correct? And this, due to this methanoic acid, that causes blindness and death, even the death also. So in our body, ethanol is produced in a large quantity, means more quantity. Methanol is not produced. Okay, methanol is generally it will be less quantity, negligible, but ethanol is produced more. But if people say drinks methanol from the outside and it reaches to the body, then it will form formaldehyde, and after that, next step, after oxidation, it will form formic acid, and due to that, this formic acid causes blindness and death. A methanol poisoned patient is treated with giving intravenous infusions of diluted ethanol. Okay, if any person has taken methanol, then a methanol poisoned patient is treated with giving intravenous infusions of diluted ethanol, so that effect will be less. Ethanol, quickly they will be treated with ethanol. The enzyme responsible for oxidation of aldehyde to acid is swamped, allowing time for kidney to excrete methanol. Second step treatment I am talking about. First, alcohol is used there. It is infused, intravenous infusion of diluted ethanol is done, first treatment, and this is not sufficient. Then the enzyme responsible for oxidation, enzyme is required, just like a biological catalyst. The enzyme responsible for oxidation of aldehyde to acid is swamped, allowing time for kidneys to excrete methanol. Okay, that will be this things enzyme will be given. The enzyme responsible for oxidation of aldehyde, that they want to stop, that step should be stopped. Means aldehyde should not again convert to this acid, means formic acid. Then for that purpose, a special enzyme is used, and it will try to remove through kidney, because through kidney that aldehyde will go outside through urine. It will go outside. Okay, the enzyme responsible for oxidation of aldehyde, means formaldehyde, to acid, means formic acid. Okay, that step they want to stop. Aldehyde should not convert into the acid. For that purpose, a special enzyme, the enzyme responsible for oxidation of aldehyde to acid, is swamped, is removed, allowing time for kidney to excrete methanol. Okay, it will can say this things methanol will go outside. That is the treatment. Enzyme is here plays enzyme role that should not be present. Then automatically this acid will be not formed, and further methanol should go outside through kidney. Now next reaction I am telling you, that is the reaction of phenols. Till actually whatever I discussed, that was related to ethanol. Ethanol reaction I have discussed due to the breakage of O and H bond, and second due to the breakage of C and O bond. Okay, now I am going to discuss reaction of phenols. Then here this phenols will show electrophilic aromatic substitution. First reaction, it will show electrophilic substitution reaction. Okay, this is the important reaction in phenol. Second will be halogenation. Okay, then these two reaction now I will discuss. Then here actually other reactions also there. Then these two reaction today I will discuss. Okay, now here you can see that in phenols the reaction that takes place on the aromatic ring are electrophilic substitution, means E plus will join E plus. The OH group attached to the benzene ring activates it towards electrophilic substitution. If OH group is attached to the benzene, because it is phenol, the OH group attached to the benzene ring activates it towards allophilic substitution. For the electrophilic substitution, OH is responsible. Okay. Also, it directs the incoming group to ortho and para position in the ring. As these positions become electron rich due to the resonance effect caused by the OH group, means coming group will go to the ortho and para because they are electron rich. Okay, then here you can see common electrophilic aromatic substitution reaction taking place in phenols are nitration. Nitration is common. Then here nitration means NO2, N will have positive charge, that's why it is called E plus. Then nitration I am discussing. While dilute with dilute nitric acid, in presence of dilute nitric acid at low temperature, means 298 Kelvin, phenol yields a mixture of ortho and para nitrophenols. It will form both orthophenol also, nitrophenol also. Okay, both it will form, and one NO2 will go at ortho position, and other will go at para position. Okay, then here the ortho and para isomers can be separated. Both are forming nitrophenol, ortho nitrophenol and para nitrophenol. The ortho and para isomers can be separated by steam distillation. Ortho nitrophenol is a steam volatile. It will mix with the steam due to intramolecular hydrogen bonding, while para nitrophenol is less volatile. Para nitrophenol is less volatile. It will not go with it will not go with steam. Okay. Para-nitrophenol is less volatile due to intermolecular hydrogen bonding, which causes the association of molecules. There are two types of bonding, intramolecular and intermolecular. Then here these things, orthonitrophenol is steam volatile due to intramolecular hydrogen bonding, means that OH present in the phenol and NO2 present on the benzene, it itself will make bond because both are attached closely. Ortho position OH is there. With respect to OH, you can tell next carbon NO2 is attached. Then both are close. Hence, OH present at ortho position. Anyone, both are respect to each other, ortho position. First and second carbon you can understand. Suppose carbon is OH is attached to first carbon, NO2 is attached to second carbon. Then their hydrogen bonding will take place. H of OH and O of NO2 both are close. They will make hydrogen bond. Means O and H weak bond it will make. Then in molecule itself this bonding is going on. Then in molecules itself bonding is going on, hydrogen bonding is going on. Then that is called intra-hydrogen bonding. Then this happens with orthonitrophenol, which is steam volatile due to intramolecular hydrogen bonding. Okay, it is a steam volatile, it will go with steam, while P-nitrophenol is less volatile due to intermolecular. Now because it will make bond. It will make bond with water. Then it will be very heavy. Correct? It will. What if vapors are there? More vapors are there. Then it will make more bond with water molecules. It will become heavy. Then it will be not volatile. But here this orthophenol, they will not make such type of bonds with water molecules, because they are making bond only with nitrogen, NO2 present on benzene ring. It will not make bond with water molecules. That's why it will mix with water steam and it will go outside. But phenol, they will make bond with the water molecules of steam and it will become heavy. Then it will not go. It will not go with steam. Hence it can be separated. Okay. Then now I have told about this nitration. With concentrated nitric acid, I told you this happens in presence of dilute nitric acid. This nitration, what I discussed, that is in presence of dilute nitric acid. Now if concentrated nitric acid is there, then what will happen? With concentrated nitric acid, phenol is converted to 2,4,6-trinitrophenol. Now here you have seen only one NO2 group attached when it was dilute, but when it is concentrated, then 3 NO2 will attach with carbon, 3 NO2, and it will form 2,4,6-trinitrophenol. The product is commonly known as picric acid. Question is asked. 2,4,6-trinitrophenol is called picric acid. Correct? Then this question is asked, you should keep in mind. The yield of the reaction product is poor, not more. It will give less. Okay. Then phenol plus HNO3, concentrated HNO3, it will give 3 NO2 group will attach. OH is there. With respect to OH, carbon number 2, NO2 will be there. carbon number 4 NO2 will be there, carbon number 6 NO2 will be there. Means ortho, para and again ortho. Okay, 2,4,6 trinitrophenol it will form. This is called picric acid. Nowadays picric acid is prepared by treating phenol first with concentrated sulfuric acid, which converts it to phenol 2,4-disulfonic acid, and then with concentrated nitric acid to get 2,4,6 trinitrophenol. Means directly also can be made or a stepwise also. Means by use of this recently I am talking about, nowadays picric acid is prepared by treating phenol first with concentrated sulfuric acid. Then what will happen? Then it will form, it will convert it to the phenol 2,4-disulfonic acid, and after that with concentrated nitric acid, then it will get 2,4,6 trinitrophenol. Okay. Then this I told you about the picric acid, 2,4,6 trinitrophenol. Now come to the halogenation. On treating with phenol with bromine, means if phenol reacts with bromine, different reaction products are formed under different experimental conditions. First I am talking about when the reaction is carried out in solvents of low polarities such as chloroform or carbon disulfide, and at low temperature, and temperature is low, then it will form mono-bromophenols. Mono means one, only one bromine will attached, means phenol plus bromine. In bromine must be present in carbon disulfide. Just like water, carbon disulfide is also solvent. Water is solvent, CS2, carbon disulfide is also solvent. Then bromine must be dissolved in carbon disulfide. Temperature should be very less, 273 Kelvin. Then phenol plus bromine, it gives minor product. One ortho product it will give also, and it will be mixture actually. Ortho, that is the mono-bromophenols. Means one bromine only will be attached, but two position will be there. That is ortho position and para position. But para position will be more. It will be major product. Two product it will give, but both will be mono only one bromine is attached. That is if it is attached with ortho position, it will be minor, and if it is attached with para position, then it will be major. The usual halogenation of benzene takes place in the presence of Lewis acid such as ApBr3, okay, which polarizes the, what is the use of ApBr3 here? Then it polarizes the halogen molecules. It polarizes the halogen molecules. Okay. In case of phenol, the polarization of bromine molecules takes place even in the absence of Lewis acid. Actually, Lewis acid was required, means ApBr3 was required. Generally, it is used. The usual halogenation of benzene I am talking about, not the phenol. The usual halogenation of benzene takes place in the presence of Lewis acid such as ApBr3, which polarizes the halogen molecules. But here you can say, in case of phenol, the polarization of bromine molecules takes place even in the absence of Lewis acid. It is due to highly activating effect of OH group attached to the benzene ring. Okay. Now second condition I am telling you, when phenol is treated with bromine, when phenol is treated with bromine water, then what it will form? It will form 2,4,6 tribromophenol. Okay, it will give white precipitate. When phenol is treated with bromine water, 2,4,6 tribromophenol is formed as white precipitate, just like a curd. If you add bromine water, you will add in the phenol, liquid phenol, melted phenol, then as soon as you will add few drops of bromine